I'm Julia Signell. I work at Element 84, which is a geospatial consulting company, and I also spend my time thinking about STAC a lot, mostly in the context of this NASA Impact Grant, which is what it's funded me to be here today. So, back a step. So this is kind of a different style talk than I've given before, mostly because I didn't do anything. I was just reading a bunch of stuff that people have been talking about over the past 6 years about how to use Zarr and STAC together. And so I'll be drawing on all those conversations and trying to pull out what the approaches should be. But I'm not totally sure I've got the right idea. So if you have ideas or if you think I'm totally wrong, let me know. So why is this interesting now? There's been a bunch of development in Zarr and STAC over the last year or so that I think makes this something that is interesting again. In particular, I want to highlight like Zarr v3 with the sharding spec, which makes it so you don't have to have every single one of your Zarr chunks be in its own object and object store. You can have chunks within one object. Also, virtual Zarr is this, it's kind of spread across a couple different technologies. There's Kerchunk, which has been around for a while, but basically and there's also IceChunk and virtualized Zarr for constructing these things. But basically what they're all trying to do is allow you to access your data as if it were Zarr, even if it's in a legacy format like NetCDF and HDF5. So you don't have to duplicate your data. You can just make it more cloud optimized by pulling out some chunk metadata, basically. There's also, in the X-ray world, there's the concept of the X-ray data tree is now a first-class X-ray data structure, same as a data array and a data set. And that's powerful because a data tree is a nested hierarchy of arrays that potentially have different dimensions and they have their own metadata associated. And if you're familiar with Zarr, that is also what Zarr is. So the data tree allows us to fully represent the Zarr data structure directly in X-ray without having to make decisions before you load it. And then in the STAC world, there's the collection search, which has existed for a while, but it recently got implementations in STAC Fast API and in PyStack Client. So that makes it easier to search not just across your stack items, which is what we typically think of, but also across your stack collections, which is really powerful, particularly in the Zarr use case. So you know this stuff, but I want to just go super high level and think about like what even is STAC and what even is Zarr, because I think that really points out like why this has been sort of an open question for a while of how to use them together. So STAC is a specification for defining and searching any type of data that has spatial and temporal dimensions. So it's about searching, it's about discovering. Zarr is a self-describing hierarchy of chunked multidimensional arrays. So it is always about arrays. But they both support flexible hierarchies of arbitrary metadata. So it's because Zarr is a self-describing format, there's often a lot of metadata associated with particular groups or particular arrays, and it's all in that file. And STAC also wants to hold that metadata. So there's kind of this contention of like who gets the metadata, who needs it, and that's where it's a little bit problematic. So here's a bunch of differences between STAC and Zarr. I'm not going to go through them all. But the main thing is Zarr is a data format and STAC is not. STAC only cares about metadata. So some data consumer questions might be, how do I discover data sets that might be applicable to my use case? Say you care about sea surface temperature. How do you find data sets that are about that? I don't know if that question, I don't know how much that question actually exists. Like maybe people don't have that question. I don't know. Tell me if you don't think that's real. But the other one is, I know I want to use a particular data set, but I don't know how to find it or how to access it. And for both those, you need a catalog. You need somewhere where you can go and say, like, what even data is there? A Zarr store sitting on S3, it's public, it's open, but it's not discoverable. So it's not, there's no way to find that other than talking to people, which is a good way. Some data producer questions might be, where should Zarr source go in a STAC catalog? And how much metadata should I pull up out of Zarr into STAC? And I think it depends on the shape of your data. So I have two images of data here, unaligned data, which I tend to think of it as like satellite imagery, like you have scenes, they're maybe at different angles, they have different grids, maybe they have different coordinate reference systems. So they're on grids, but they're kind of different. And this is also can be thought of as like level 1, level 2 data in the data processing levels framework. Also, this is all a simplification. These are showing 2D and 3D, but this can all be like higher dimensionality. And then you have the aligned data, which is the data cube that you think of. That's like that's the Earth systems models that have a regular grid. They are normally global in scale. And with those, like maybe you also have a couple of those in one Zarr store. Maybe they have different resolution. Maybe you have the same, different variables. So another simplification. So I'm going to go through those two kind of different scenarios and propose where they should go in the STAC catalog. So there's the one big Zarr. That's the data cube, Earth system model, level 3, level 4 data. So you have your data in S3. It's just one big data store. And then you have your STAC collection with an asset that points to the data store. That's kind of this is called a standalone STAC collection, I think. So the idea is you don't have items. It's just the collection that points to the Zarr store. And then you have some ideas about when you ask how much metadata should I abstract out of the Zarr and put in my STAC, I think it kind of depends on what you want your users to be able to do. So the simplest possible case is you just have a collection with an asset that points to the store. So that's down here. Oh, I'm going to be showing a couple of these graphs where it has usefulness to people and the effort required by you as a data producer to maintain this thing. Because that's kind of the trade-off, right? And the effort, I mean, both in terms of the cost of storing it, the cost of generating it, the cost of keeping it up to date. And I think you really want to be weighing those two axes when you're generating STAC metadata. So down here, I just think that this is a genuinely useful thing, right? Of just the simplest possible catalog where you just have the asset that just points to the store, and that enables people to find how to access known data sets. So if they say, I want CMIP6, they can go and they can find where that is on S3. And that's useful. But then you can also keep going, right? You can, the next thing that's useful, most useful and lowest effort, I think, is the collection level cube variables. So using the data cube extension, you can pull metadata up at the collection level that just talks about what the variables are, that takes the attributes from Zarr and pulls them up to the collection level. And that enables people to discover new data sets. That's where you can search for sea surface temperature or for ice or something. And then this is a little more avant-garde maybe. But this is the collection level link templates. It's not quite there yet, but the idea is that you would be able to have a link template which would allow you to access a subgroup within a Zarr directly without having to go through the Zarr, without having to open the Zarr in the first place. So some of the things to think about there are STAC metadata in this scenario is only for search and discovery. It's not for filtering. So if you have metadata that's only useful for filtering, maybe you don't need to pull it up into STAC. And this is kind of a downside, if your extents are bounded, they need to be updated whenever the data is updated. But in a lot of these cases, the spatial extent is global, and the temporal extent, Matthias told me, it doesn't have to be bounded. So you can have like an open end time. Okay, so now we'll get into the smaller Zarr's case for unaligned data. So this is more of a, this is more like satellite imagery where you have these different data sets. Maybe they each represent a scene. They're kind of smaller in spatial extent. And this is this is how we typically think of STAC, right? This is like how STAC plus COGS looks, where you have STAC items that point to each of these different assets. And this, and then, so it goes in the same place that a COG would go, but you might just have one instead of maybe in the COG scenario, maybe you'd have one for each band. And in terms of how much metadata to abstract, again, like it's useful just to have the item level assets. You probably also need to have the extent so people know which one they need to use. And then I think something that's really useful from a search and discovery perspective is having collection level summaries and item assets, which will enable you to do collection search. So you can see the variables that are contained within all the Zarr stores at the collection level. And then item level, cube variables, cube dimensions, that can get really verbose, and I'm not totally sure how useful it is. So this is a less common use case for Zarr, the scene level Zarrs, but it's going to get more common. People are probably aware that ESA is planning to distribute Sentinel-2 L2A data as Zarrs. So this will happen. Some of the issues with it are Zarr is still young compared with COGS, and certainly with TIFFs, like COG is building on an existing format. So there's less around about how to visualize Zarr, for instance. Also, the exploded file hierarchy is problematic, but the sharding can help with that. It can limit the total number of API requests you need to do to access your Zarr. This is kind of like a wildcard extra slide, but this is the virtual references part, where this is kind of proposing how you would store a virtual reference in STAC. And this is what Planetary Computer does right now with CMIP6 and some of these other data products that are stored in NetCDF files. And so the idea is that you have STAC items that point to the NetCDF files, and then you have a top-level collection asset that points to the Kerchunk file. And that allows you to, the Kerchunk file, so you just need to do one get to get that Kerchunk file, and then you have this entire lazily constructed data cube that you can then go and reference the individual NetCDF chunks directly without having to read the metadata from each NetCDF file. So if you have NetCDF files, this is kind of like the best case scenario for users. Okay, so these are all the different discussions that this is pulling from. You can see they go way back. And it's been really interesting to read through all this. I'm hoping that I've captured the idea as well. And I also wrote a blog post that's basically the same thing as this, but maybe a little more verbose. And then I'm working with some DevSeed people on the cloud-optimized geospatial formats guide. I was hoping it would be done by now, but it's not. But that's an even longer report-style thing, kind of going into this in more detail. All right. Any questions?
Yeah. Do you think ACE's use of Zarr is a good idea?
I don't know. I think there's a lot of work that's gone into COGS, and they're really good at what they're good at. But I think that this is an interesting opportunity for us to try and get in there early and try and make sure that they're doing the best possible thing that they can, given this decision.
It's decided, yeah.
Pete?
Yeah, did you, and this is a bit of a leading question, but did you look into pulling all of the Zarr metadata into an item and the downsides and upsides of that? Because I know that's been proposed.
I didn't. I was trying to focus on like I think the core question is like, what is useful for a stack to have? And I think that doesn't get enough attention sometimes. So I mean, to be clear, I didn't do anything, right? Like I was just reading stuff and thinking. But yeah, I think that if you think there's a genuine use case for your users to have all the Zarr metadata at the stack level, then go for it. But I think that it's intimidating for people to see that and to think that they need to do that. I also think I might have forgotten to mention that Tom Augsburger made an amazing tool called XStack that allows you to pull, once you have an object in Xarray, so once you've opened your Zarr, you can pull all the metadata out and into Stack with that. So you don't have to like do this by hand.
It's great to know now that I've already done it myself.
Yeah. It's helpful, right? Okay, thank you.